Welcome. In this lecture, we're going to talk about some of the background we're going to need in order to talk about horizontal asymptotes and limits at plus minus infinity for rational functions. So let's start with, a rational function looks like, a rational function is going to be a function that looks like, rational function, rational functions, right, they look like, so what do they look like? So they look like where you have some kind of polynomial divided by a polynomial. Okay, so this is a polynomial, and this is a polynomial. Great. So let's just kind of look at some examples really quickly. So here are some examples. We can have 2x cubed minus 1 over x plus pi. So 2x cubed minus 1 over x plus pi. Okay, that's totally okay. You've got a polynomial on top, a polynomial on bottom. It's okay for any of your coefficients to be irrational numbers. They don't have to be fractions or integers or anything. We could also have, for example, we can do x squared. Okay, so why does that work? You don't see something on the top and something on the bottom. Well, that's actually equal to x squared divided by 1. Okay, so that is something that's a polynomial divided by a polynomial, because constant polynomials, like 1, are polynomials. So here's another example. Just like we can have 1 on the bottom, we can have 1 on top. Maybe I'll do this example here. So here's another example. It's okay to have 1 on top, any polynomial on the bottom. Here's something to get like a little bit crazier. So let's do pi x. So it's okay, as I said, that any of our coefficients, they can be rational numbers. They don't have to be integers. And then maybe we're going to, but that one's not okay because I meant to write an x there. I mean, it would be, but for more of a funny reason. I want it to actually be the coefficient of x. And then subtract off e. If I had left an e there, this entire thing just would have been a constant, which would have been okay. But I wanted to kind of show something else there, so I wanted to fix that. And then we have 1 plus x. Okay, so crazy stuff on top, crazy coefficients, totally okay. And then here's another example. So I could have, let's do another one where it's going to have to equal something. So what if I write square root of e x to the minus 2, and I want to write it as a polynomial divided by a polynomial. Well, remember when we have a minus power, that just kind of moves it to the bottom. So I have like an x squared on the bottom and the square root of e on the top. Okay. So each of these is an example of a rational number. So what can we not do? So I'll do these in another color so that it's clear. So these are non-examples. These are not rational polynomials, so we'll use a different color for them. So one example would be, and then I'll kind of explain what's wrong with it. So what if I wanted to write the square root of x divided by x plus 1? Okay, so the problem here is that powers must be non-negative integers, or at least we must be able to write it like that, because I know that this is negative, but that's okay because I can move it to the bottom. But overall, there's no way to break this down so it looks like polynomial over polynomial. Okay, so powers must be non-negative integers. So the problem here is powers must be non-negative integers. Okay. Let's go ahead and look at one more. So what if I wrote something like x divided by sine of x squared? X divided by sine of x squared. Okay, so what's wrong with this one? Which is that you shouldn't have functions allowed inside of the powers. It's just x that's inside the powers. Okay, so no functions allowed inside powers. So no functions allowed inside powers. Okay. So there are going to be 3 cases that are going to be divided up by degree. So I'll write these cases, and then let's look at what we mean by degree. Okay, so here are the 3 cases. I'm going to write them up in this corner so that we can keep them there as we go through the different cases. Okay, so I have 3 cases. Okay, I'm going to have the circumstance where, so we're going to be looking at something called the degree. So I'm going to have the degree. I'm going to make it orange for us. So the degree of, and this is going to be the bottom that's going to go inside of there, it's got to be bigger than the degree of the top. This is one circumstance. Okay, so degree of the bottom, so it's Q of x, is greater than the degree of the top, which is P of x. So this is like case or circumstance 1. So we have 3 of these. So I have 1, and then the next one, which is going to be that the degree, so now we're going to swap these, and we want the degree of Q of x is going to be less than the degree of P of x. So degree of Q of x, so the degree of the bottom is less than the degree of the top, or the polynomial that's on the top. And then the last one is that those degrees are the same. So the last circumstance will be where those degrees are equal to each other. So then we're going to kind of want to go through a reminder of what degree is here. So we have Q of x, like the bottom is the same as the degree of the top. Okay, we're going to put that in a nice little box for ourselves so that we can refer back to this over the next few lectures. These are our 3 circumstances. But then, knowing that this is here, you're going to want to make sure you know what is meant by the degree. So we're going to go ahead through that. So we'll need the degree of the polynomial. Okay, so the degree of a polynomial. Oops. Okay, let me write this in. So the degree of the polynomial, and just box it in orange. I meant to write it in orange, but it's, if I box it, I think you know that that's what I mean. So the degree of the polynomial, right? What is this? So this is like, you could think of this as like the largest power. So this is like the largest power. So let's look at some examples. Always good to look at examples. So examples. In the first case, let's look at the degree. So I'm usually write this like DEG to save myself writing out all of degree. But you can kind of see that in here. So this DEG is coming from the first 3 letters there. So DEG. Okay. So here we go. So I want to take the degree of this polynomial, and we'll go ahead and put, so this is for a polynomial, so maybe I'll go back to having this be blue. So I have 3x squared plus pi x minus 1. So I look for the highest power. So this power is 2, this power is 1, this power is 0. So it's definitely this power 2 here. Okay. So it's this 2. So I'm going to get out that the degree is equal to 2. Okay, let's try some more examples. So let's take the degree of, so I have 3 minus 2x. Okay. So looking at this, again, we want to say the degree of this is 0, the degree of this is 1. 1 is bigger than 0, so that's my degree. Okay. And then as one last example, we're going to look at the degree of, and then we're just going to look at the degree of e squared. And we're not going to get confused by that. You see a squared there, but it's not next to the x, right? It's actually, I'm just squaring the constant, so I'm still getting a constant, okay? Because so this is 0. So why is that 0? So that's going to be 0 since e squared is a constant and the degree of every constant is 0. Okay, so this is true since e squared is a constant And what was the other part of what I said, which is the degree of every constant is 0. Okay, and the degree of every constant is 0. So degree of every constant is 0. Every constant is 0. Okay, so let's just kind of go through. These are some things that we're going to need. A rational function is going to look like a polynomial divided by a polynomial. And there can be tricky circumstances, like you are allowed to have very funny coefficients. That's okay. The coefficients don't need to be integers. It's just that the powers need to be non-negative integers. Or at least you need to be able to write it so that the powers are non-negative integers. So this is a tricky one because I have like a -2 as a power, but because it's kind of like on its own there, I could just bring it to the bottom. Okay. And then we have kind of a similar thing here where I have, right, if I have, so this one has nothing on the bottom, but I could make 1 on the bottom. This one just has a bunch of funny coefficients. Okay. Non-examples, I can't have fractional powers like the square root of x. I could have the square root of e because I was just talking about a coefficient or a constant. I can't have fractional powers. I also can't stick functions, right, and square them or something like that. It just is x that I can take to powers, or the constant. And the other thing that we need is the degree of a polynomial. It goes in front, it's like the highest power. It could be tricky, it could come second. It could be 1, like if I just have x, right, the power there that's kind of secret is 1. And it's actually possible that it's 0 because I'm looking at a constant. And so you can see when you're talking about a constant, there's like a little secret thing inside of there. Like I secretly have x to the 0 next to every constant. Okay, so I hope that made some sense, and I will see you in the next lecture.